Hey folks, Mr. Bauer here. So today I'm going to show you how to work with proportions. This is a really easy skill, but it's a really important and really helpful skill in working with equations and in physics. So let me start off. Working with proportions means working with equations. Let me start off with a real easy equation that we're going to learn later on in physics. Just three variables, F equals ma. And that stands for force equals mass times acceleration. Now normally when you work with an equation, you get a question that looks something like this. What is the force if the mass is 2 and the acceleration is 3? And of course that's real easy. You know that all you have to do is plug in the value for mass, which is 2, plug in the value for acceleration, which is 3. 2 times 3 equals 6, and so that means the force is equal to 6. That's not a proportion, that's an equation, that's what you're used to. So what does a proportion question look like? It's going to look something like this. What happens to the force if the mass is doubled? So notice the difference. Up here, I gave you specific numbers for mass and specific numbers for acceleration, and I wanted a specific number for force. But in this question, I'm not telling you what the mass is. I'm not saying anything about the acceleration. And I want to know what happens to the force. So you'll notice that a proportion question doesn't involve specific numbers. It involves a proportion or a ratio. In this case, the mass is doubled. In other words, it's twice as big. So how do we solve this? Well, we take the same equation, F equals ma. And the first thing you're going to do is you're going to cross off anything in there that's not mentioned in the question. So what's not mentioned? Acceleration. Acceleration isn't mentioned at all, so you want to cross that off. It's not relevant to the question. The assumption in all of these types of questions is that what isn't mentioned is staying the same, that the mass is being doubled, nothing's happening to the acceleration. Anyway, what does that give you? F equals m, and there's no longer an a in the equation because it's not mentioned, it's not relevant. And now, really, you just treat this like an equation. What happens to the force if the mass is doubled? So I'm going to plug in, maybe I'll do it over here. I'm going to plug in for m, I'm going to plug in a 2 because that's what doubling means, twice as big. And so what does the answer tell me? Force equals 2. Now be careful, that doesn't mean actually that the force is equal to 2. It means that the force is twice as big. The answer to a proportion question is always a proportion itself. So we just found out that if you double the mass, the force is going to be doubled as well. Let's do another example. What happens to the force if the mass is tripled? Well, it's the same scenario as up here. Acceleration isn't mentioned, so we cancel it out. So we're really just working with F equals m. Tripled means 3 times as big, and so it's just as simple as being able to say force is also going to be 3 times as big. Again, the force isn't equal to 3. The force is just going to be 3 times as big. Maybe one more example with this simple proportion. So in that same scenario, what happens to the force if the mass is halved? We're going to use the same proportional equation, F equals m. I'm going to plug in a half for m, and there's our answer. The force is going to be a half as well. So you're probably thinking to yourself, can it really be that easy? Well, yeah, but that was the easiest proportion possible. That one was called a direct proportion. Let's take a look at another equation that you're going to see later on in physics. Looks like this. K, which stands for kinetic energy, is equal to 1/2 m, which stands for mass, times v squared, velocity squared. So kinetic energy is equal to 1/2 mass times velocity squared. Let's take a look at a proportional question here. What happens to the kinetic energy if the velocity is doubled? All right, so what are we going to do? We're going to cross out anything that isn't mentioned. Mass isn't mentioned at all. I'm crossing it off. I'm going to cross off the 1/2 too. You always cross off any numbers that are just coefficients, numbers that are just multiplying the rest of the things in the equation. Now there's a 2 here. It's the exponent of the velocity. I am not going to cross that off. Since velocity is important and 2 is specifically the exponent of the velocity, I'm not going to cross it off. So don't cross off exponents, but always cross off coefficients, like this 1/2, which is multiplying everything. So what am I left with after I cross those things off? I'm left with k equals v squared. All right? And what did they tell us? Velocity is doubled. So I'm going to plug in a 2 for velocity because doubled means twice as big. According to the equation, velocity gets squared, 2 squared. What does 2 squared equal? It equals 4. So that's what the kinetic energy, well, it's not what the kinetic energy is equal to. It's not equal to 4. It's 4 times as big. If you double velocity, kinetic energy is going to be 4 times as big according to this proportion. Here's another question. What happens to the kinetic energy if the velocity is tripled? So it's the same proportional relationship. K equals v squared. The mass isn't mentioned, and we always cross off any coefficients. So tripled means 3 times as big for the velocity. In this equation, velocity gets squared. 3 squared is 9. So that means the kinetic energy, it's not equal to 9, but it's 9 times bigger. The kinetic energy is going to be 9 times bigger. How about one more example with this equation? What happens to the kinetic energy if the velocity is halved? It's the same relationship, k equals v squared. Just going to plug in a half for the v. I'm going to square it. A half squared is 1/4. So that's what happens to the kinetic energy. The kinetic energy is going to be 1/4 as big. So hopefully you're getting the hang of this now. We're not plugging in specific numbers. We're plugging in what's happening to one thing and finding out what's happening to something else. All right, let me give you another example. This one's a little tricky. What happens to the velocity if the kinetic energy is doubled? Now you might notice this is a slightly different question. Here I'm telling you what's happening to the kinetic energy. Up here I told you what's happening to the velocity. It's the same relationship, k equals v squared, because we're not dealing with the mass at all and we cross off that half from the equation. It's just that this time I've been told about the kinetic energy being doubled. So I'm going to put in a 2 for k, and what I don't know about is what's going to happen to the velocity. So I have an equation here that says 2 equals v squared. Now you know how to solve this. You take the square root of both sides. And so what we end up with is the square root of 2 equals v. So what does that mean? Well, it simply means that the velocity is not equal to the square root of 2. The velocity is the square root of 2 times bigger. That might seem really weird to say, but look at it this way. The square root of 2 is approximately 1.4. So it really just means that when you double kinetic energy, the velocity is 1.4 times bigger. So let's say the velocity was 10. 1.4 times 10 is 14. So then the velocity is 14 times bigger. All right. One final example here for you. One different equation. Here's another equation that we're going to see later on in this class. F, force, equals m, mass, times v, velocity squared, divided by r, radius. This is for something moving in a circle. So what happens to the force if the radius is halved? Well, what are we going to cross off? We're going to cross off mass. It isn't mentioned. We're going to cross off velocity and the fact that it's being squared because velocity isn't mentioned and that square is attached to the v. So we're just left with F and R. So the equation ends up looking like this. F equals, now there's nothing left on the top, so I'll just do a 1 as a placeholder. R on the bottom. F equals 1 over R. The radius is halved, so F equals 1 over 1/2. 1 over 1/2 is 2. What that means is if the radius is halved, the force is going to be 2 times as big. The force is going to be doubled. All right, here it is. Last example. Maybe the trickiest possibility here. Two things happening at once. What happens to the force if the radius is halved and the velocity is tripled? So let's go back to our original equation. F equals mv squared over r. And let's cross out anything that's not being mentioned. There's no mention of mass. There is a mention of velocity. There is a mention of radius. So I'm going to leave them in there. And our new equation is going to look like this. F equals v squared over r. So it says the radius is halved, the velocity is tripled. Let's put those things in. On the bottom, I have 1/2 for radius. On the top, I have 3. And remember, velocity is getting squared in this equation. 3 squared on the top. So that gives me 9/1/2. And that's the same as 9 times 2. So the answer is 18. The force is not equal to 18. The force is going to be 18 times bigger. So hopefully you've got it now, and you'll find that the more comfortable you are using proportions, the easier a lot of questions become. So good luck with that.